This video is going to go over some application problems on page 14 of your packet, and we're going to use SOHCAHTOA and our calculators to help us answer the question. So the goal is to draw a picture. So we're going to draw a picture to represent this first problem. It's saying a surveyor is standing 50 feet from the base of a large tree. The angle of elevation is 71.5 degrees. We want to find out how tall the tree is. So we want to think about how we could sketch a right triangle to demonstrate this situation. So we would know the tree, we would hope, right, would be standing straight up. And if it's a right triangle, it's going to be perpendicular to the ground. So I know I'm going to have a right triangle. This is going to represent the tree. Now the surveyor is standing 50 feet from the base of a tree. Now think about the base of a tree. The base is the bottom. So the surveyor has to be standing out here 50 feet from the base of the tree. The angle of elevation. So when we think of the word elevate, that word means to rise, to go up. So if we're thinking of an angle of elevation, it can't be the right angle. It wouldn't be the one in the air near the tree. So it's going to be this angle right here, 71.5 degrees. That's that angle. We want to find out how high or how tall the tree is. So I'm going to call it H. We could call it X. You could call it anything you like. But we have to figure out from SOHCAHTOA, because we can use those for only right triangles, would the information given work out best if we use the sine, the cosine, or the tangent? Now think about sine and cosine. They both have the hypotenuse involved, and the hypotenuse is the side across from the 90-degree angle, or the largest side of the triangle. And we were given nothing about the hypotenuse, so we don't want to use that. So we're going to stick with using the tangent. So we're going to do the tangent of 71.5 degrees is equal to opposite over adjacent. So H over 50. Now we want to be in degree mode. And when you think about fractions, that tangent of 71.5 degrees is over 1. So we can cross multiply. And we'll get H equal 50 times the tangent of 71.5 degrees. There's a decimal point there. And then in our calculator, we would type in 50 times the tangent of 71.5 degrees. And we're going to round to 2 decimal places. We'll get 149.43. Make sure you can do this on your calculator, and then include the units. Okay, the second question we're going to try to set up. A person is 200 yards from a river. Rather than walking directly to the river, the person walks 400 yards along a straight path to the river's edge. So we have to think about what this is referring to, and we have to make a right triangle. So I'm going to let this be the river, and the person is 200 yards from the river. Now I could draw this a couple different ways. I could have the person here, or I could have the person here to make my right triangle. It really doesn't matter. We just know that this is our right angle if we're doing it this way, or if we were doing it on the other side, that we'd have a right angle as well. And the person isn't in the water. They're 200 yards from the river. So this distance is our 200 yards. Now rather than walking directly to the river, the person walks 400 yards along a straight path to the river's edge. Well, the only other side that we're going to have for this right triangle, because the person would not be walking in the water, would be this distance. And this is where you have to use a little bit of logic when you're setting these up. And sometimes that's where we have problems. So we want to just be careful to make sure it makes sense when we set it up. They want us to find the acute angle. So we know the person's walking 400 yards. That would be the hypotenuse. We want to find the acute angle between this path and the river's edge. Well, we have two angles to choose from. We have this angle here, but this angle would not be the path with the river's edge. So we're going to use this angle because it is the path with the river's edge. So this is going to be our theta. So again, once we have the triangle set up, we want to figure out what is going to best help us solve for angle theta in this case. Would we use the sine, the cosine, or the tangent? Well, I'm looking at that angle, and if I go directly opposite, that's the opposite side, and this is the hypotenuse, so the pieces that are given, the sine function would be the one that would make the most sense. So we're going to do sine of theta equals the opposite side, which is 200, over the hypotenuse, which is 400. And that reduces to 1/2. Now, our calculator's mode is in degrees from our last problem, so we're going to get our answer in degrees. And what we're going to have to do to get this, and this is where you need to practice on your calculator, we're going to find out the angle whose sine is 1/2. So we're actually doing the inverse. So what we're going to hit on the calculator is second, and then the sine button of 1/2. What that will do is that will give us the angle theta, and this angle theta is in degrees. So go ahead and do that second sine of 1/2, and we'll get 30 degrees. Okay, so you try to set up the third one using a little bit of logic. Okay, we have a flagpole that we're assuming is standing up, and there's going to be a shadow. Now the shadow is not going to be in the air, so the shadow is going to be along the ground. And again, all of these are going to make a right triangle situation. Finding the angle of elevation, two choices. Elevate means go up, so it's going to make sense that that is angle theta. Figure out what trig function would work. The side we know nothing about is the hypotenuse, so we don't want the hypotenuse involved. So out of our three trig functions, we have the tangent. So tangent of theta is opposite over adjacent. Now again, we're going backwards and we're trying to find out angle theta. So we're going to do the inverse of the tangent on the calculator. And since we're in degree mode, our answer will turn out to be in degrees. And round to 2 decimal places. Okay, so those are the notes from page 14. What that's going to help you do now is to work on the special right triangle packet. I don't know if I have it in here, on worksheet 3. So that special right triangle packet where you already did worksheet 1 and you already did worksheet 2, you can now work on worksheet 3.